Today, we're gonna go through a question I heard a while ago. Basically, there's this teacher was talking to his class of roughly 30 students. He said, "I'm willing to bet $1,000 that at least two of you share a birthday." Now, at first glance, we most people seem to think that because you have 30 kids in a class and there are 365 days in a year, let's assume there's all the years have 365 days. It seems like that it's very unlikely that two students will share the same birthday. But that's the appeal of math, right? Sometimes things are just not what they seem to be. In this case, if we look at the problem at hand from the perspective of statistics or probability, we can basically say, what's the probability of all the kids have different birthdays? And that's a little easier angle to take than just go straight say at least two kids share the same birthday. Because if you go directly at it, you need to figure out what's the probability of two kids share a birthday, three kids share a birthday, or six pair of kids share six different birthdays, so on and so forth. There are a lot of different scenarios, and you need to break down in order to get a complete picture of that answer to the question. If we can figure out what's the probability of all the kids would have different birthdays, then we just take 1 minus that number. That will give you the answer to the original question. So let's ask ourselves, what's the probability of all 30 students have different birthdays? So for all of you who have already taken probability in math in high school, you know that the probability of all 30 kids have different birthdays is P 365 30. Or in some textbooks, it's written like this: 30 P 365. So basically, if you imagine those 365 days as, let's say, boxes, you try to put 30 balls into those 365 boxes. No two balls will be in the same box. And then we look at what's the total number of arrangements, every scenario included, right? That would be 365 to the power of 30. Then the probability that all the 30 students will have a different birthday would just be this divided by this, right? So which is 30p 365 divided by 365 to the power of 30. And this top one becomes 365 divided by 335 times 365 to the power of 30. And if you go through your calculator or Excel, you will figure out that this is roughly 29%. In other words, there's 29% chance that all 30 students will have unique birthdays. That will leave us 71% chance that at least two students will share the same birthday. In other words, that teacher would have 71% versus 29% chance to win the bet. Now, let's say if you haven't taken any probability classes or advanced, statistics classes, you don't know these notations. What you can do is you break down the task into multiple steps. So you have 30 students, you try to put into different days of the year, right? So when you have the first student, for that student, there are 365 choices for him or her. And then for the second student, because we said no two students share the same birthday, for the second student, his or her choices is decreased by 1, and that's 364, because the first students already picked a day. And then the third students would only have 363 choices. So these are the choices for each student. And there are 30 steps we need to complete this task. And at the end, it would be 336. So when you multiply these numbers, these are the total number of arrangements that for all the kids who will have different birthdays. And you take that divided by the total number of arrangements, again, which is 365 to the power of 30. That will actually give you the same answer. But this method doesn't require you to know the notations of these notations. But instead, you just need to know the basic principle of probability. So that's it for our episode number 4. Thank you.